Hello everybody, this is a short video that describes the banana smell enzyme processing kit by Amino Labs. Within this video, we're not going to show the enzyme, but we're going to look at the underlying chemistry that happens to convert isoamyl alcohol, which doesn't really smell, into isoamyl acetate, which does smell. And for this reaction to happen, there are two important substrates or reactants. We've got one which is called acetyl-coA, and acetyl-coA is on the left here. It is made up of carbons, which are the gray spheres, oxygens, which are the red spheres, hydrogens, which are the white spheres, nitrogens, which are the blue spheres, and phosphorus, which is the orange sphere. And at the end, there is a yellow sphere, which is sulfur. Now, acetyl-CoA is a combination of two molecules, you could say. You've got the CoA, which is everything up until the yellow sulfur group. And then the acetyl group is this end group here. All right, and as you will see, this is going to be a very important player in the chemical reaction. So what first happens in the chemical reaction with the enzyme is that the acetyl-CoA is bumping around and ends up encountering the enzyme that you've created. The enzyme then has to break a bond. And the bond that it breaks is this one right here. So the enzyme, once it's bound, it will break this bond, freeing up an acetyl group or an acetate group. Okay? And as this happens, there is the formation of a hydrogen on the sulfur, like so that it remains stable. And then what happens is this acetate group is transferred over to the isoamyl alcohol. So now we'll look at that. The isoamyl alcohol is made up of carbons, which are the gray spheres, hydrogens, which are the white spheres, and oxygen, which is the red sphere. Okay? And what the enzyme does is it attaches the acetate group to this oxygen down here. Okay? And let's do that. What happens is this molecule goes something like so. And then what happens is there's the creation of a bond. Right there. All right? And once you have that bond, now we have the molecule isoamyl acetate. And what we could do is we can now see what this would look like by running a simple optimization algorithm. You can see it's slowly optimizing its shape based on the energy. And the optimization algorithm can run for a while, so I'm going to stop it because this is going to be pretty close to its theoretical shape. So there we have it. We now have isoamyl acetate, which is the molecule that smells somewhat like banana. So just to recap, for this reaction to happen, first the bond on the acetyl-CoA between the sulfur and the acetyl group needs to be broken. And that is normally a fairly stable bond, and the enzyme is critical in catalyzing the breakage of that bond. And then further, that acetyl group is transferred over, and a bond is created between the carbon of the acetate group and the oxygen of the isoamyl alcohol. This reaction without the enzyme would not normally happen, or it would happen very infrequently. And that's why enzymes are so amazing, is that they are very specifically able to cause chemical reactions to happen that would not normally happen.